So, very good morning to all members. Today we are in the day 2 lecture series in design of experiments. In this session, we are going to discuss about analysis of variance Anova. Let us quickly move in brief about what is meant by analysis of variance, how that can be used for finding out the significant difference statistically between each factors in order to signify the given output response variable. Let us go as per further direction. Before moving on to the topic, let us start with the basic objectives of analysis of variance. The Anova is one of the methodology under design of experiments. The primary purpose of Anova experimentation is to determine whether there is a significant difference between each group or not, and find out the variance between each group if there is found to be a significant difference. How we can able to find out the significant difference between each group using F-test in statistics. So with the help of the F-test analysis, so we can able to find out the difference between each factor in the experimentation. So now, what is meant by ANOVA, analysis of variance? See, ANOVA is a statistical tool used in design of experiments, which is used to analyze the basic fact or information, and it will try to determine the significance of various factors on an outcome. Outcome is nothing but the final output which we are going to get from the experimentation process. How reliably the outcome of the experiment based on the given input parameters. That is what we are going to see here in this topic. DOE is a structured approach for planning various experiments, collecting data and analyzing the results to optimize the process and understand the relationship between input and output variable. ANOVA helps to identify which factors are significantly affecting the output response variable and their effects. How ANOVA can be used in design of experiments. After gathering the data from an experiment, ANOVA is used to analyze the results and determine the statistical insignificance of various factors. ANOVA helps to identify which factors have more significant effect on the response variable, while also considering the interaction between the factors, that is group interaction between various multiple factors. Smaller the p-value, more likely the factor has a significant influence on the response. So the p-value which will try to fix the significant variation between each factor. Say if the p-value alpha is equal to 0.05, so that will be the level of significance to find out the reliability of each factors which has been included in the experimentation process. What are the various types of ANOVA in design of experiments? Two-way ANOVA, that is two-factor ANOVA. So this is used for analyzing the experiments with the two factors only. and we have to find out what is the interaction between them. Multiple way ANOVA, that is multifactorial experiment. So this type of ANOVA used for analyzing the experiment with more than two factors. Here also we can permit the interaction between multiple factors for further analysis. One-way ANOVA is used for only one single factor with multiple levels. So these are the different classification of ANOVA in design of experiments. What are the benefits of using ANOVA in design of experiments? See, one thing we can able to pinpoint, we can measure the significant difference between each factor and which one is highly influenced with respect to the output variable. Next one, we can able to determine the optimal settings for achieving the desired outcome from the experiment. And we can able to reduce the time of experiment, identifying the most important factor. ANOVA helps to reduce the number of experiments needed by fixing the most important factor. Process optimization. So ANOVA provides a statistical foundation for process optimization by identifying the key factors and their following interactions. Now we will try to have a numerical example for the theoretical based on the theoretical principle and foundation. For that, we will try to have this numerical example, one-way ANOVA using Minita software. So consider a chemical engineer who wants to compare the hardness of four different blends of paint. The six samples of each paint blend were applied to a piece of metal. The pieces of metal were cured for some time, and each sample was measured for hardness individually in order to test the equality of mean and to assess the difference between the pair of mean. The analyst uses one-way ANOVA with multiple comparison. So this is the problem case study. So what are the steps, procedures to be followed using Minitab software? First, try to open the sample data page, save them under the name paint hardness dot extension file. Go to the toolbar menu, choose statistics, select ANOVA, type of ANOVA, one-way ANOVA. Then select the response data in one column for all factors level. In response column, enter the hardness. In factor column, enter the paint. So four different blends of paint, that is the input variable. Hardness is the output response variable. Then click the comparison button, then select the Tukey method. It is one of the statistical method to find out the significant difference between various multiple pair. Then click OK in each dialog box. Let us see the detailed workup. So these are the results obtained through one-way ANOVA experimentation. From these results, we can infer that the p-value for the paint hardness is less than 0.005. So this results indicates that the hardness of the paint blends differs significantly with respect to each other. So the engineers knows that some of the group means are different. So here the calculated F value is 6.02, whereas P value is 0.004, which has a huge significant difference. So the source of variation between various samples of paint having different measure of hardness. So this clearly shows that the hardness are slightly ranging from different level. So the engineer uses the Tukey comparison results to form whether the difference between each pair of group is statistically significant or not. So from this table, the blend 4 and 2 have vast significant difference in terms of the range. The hardness for the blend 2, sample number 2, 3.114, and for the sample 4, 18.07, which has a vast difference, significant difference in terms of hardness. For a given error percentage of confidence interval, 95%. So the same thing can be tested in graph, that is interval plot of hardness versus paint. X-axis considered as different sample of plain paint and y-axis hardness value. So the blend of 1, the hardness is found to be 50, and the second sample blend number 2, so nearly 8 point between 7.5 to 10, and third sample between 12.5 to 50. The last one between 17.5 to 20. So the maximum hardness here, blend 4, the sample number 4, compared to the other 3 sample, which has the highest level of significant difference, and that is considered to be the more dominating one. So we have to group fourth sample in the first order and the other remaining 3 samples according to the relativity of the significant difference. We have to group it. So what is the conclusion from this experimentation? In summary, Anova is one of the most important essential tool in DOE for quantifying the impact of different factors on a response variable. So in this experiment, the response variable is nothing but the mechanical hardness of the paint, whereas input factors are nothing but 4 different samples of paint. So based on that, we can understand the relationship between the factors and also the output response variable, and we can make much more reliable decisions about the optimizing process or a products. So this is how the ANOVA experimentation can be solved using either manually or using Minitab software. So with this, I thank each and every one of you. We will see later in the next couple of lecture under the same domain design of experiments. Thank you all.